All right, check, check, 1 2 1 2, check, check, 1 2 1 2. Just making sure that the audio is good. So if it's good, I'm sure nobody is watching right now, but if anyone's watching and you can't hear my audio, feel free to leave it in the chat. But I'm Donald, and I'm just gonna live stream my Leetcode grind streams. I do have a meta interview coming up, so I thought I'd just live stream this and kind of show you through my process. So it is pretty late, I just got home from work in the gym, so my mind's not like at 100% right now. So what we're gonna do in this live stream in particular is I'm gonna go over all the problems that I actually do know, and I'm basically gonna go through and try to explain my thought process as I would in an interview setting, right? So it's not going to be much on the problem solving aspect of it, but more or less from the more of a, how do I describe this? It would be more of a you know, just, reiterating everything, making sure that you're vocalizing your thoughts as you do in most interview settings. So let me just get all of this stuff set up. So as you can see here, I am in the top Facebook questions. I did end up having to fork over, like I did end up forking over $35 to Leetcode in order to gain access to this stuff. But you know what? It's worth it to me, especially when you're preparing for a big interview. I think that $35 is a low price to pay for the ability to get, the data like this so that you can really focus in your study, right? So what I'm going to do is I'm basically going to go down this list from top to bottom, see which ones in terms of the problems that I know, and then we're just going to vocalize our thoughts here. All right? So I'm just getting some of the stream stuff set up real quick here, and then we will get started on some problems. Just give me a moment, guys, while I set everything up from the stream aspect of things. All right, so everything's set up now. So what we're going to do is we're going to get down to business. So I'm going to start with merge intervals here. This is a pretty classic problem here. I've done this a couple times. So as you can see here, it's auto-completed. I'm going to clear that. So say that I'm presented with the problem merge intervals, given an array of intervals where intervals I is start end, merge all overlapping intervals, and return an array of non-overlapping interviews that covers the intervals in the input. So basically, what we see here is we get a list of integers, and basically what we have to do is if these two integers were to match up, then we would want to return that, right? So what I'm going to do for explanation purposes and my thought process is I'm going to get my good old trusty web whiteboard here, create a new board. All right, here we go. So I'm gonna go 1. Oh man, this pen is kind of shit. Pen, smart drawing. There we go. So 1 3 2 6. And actually what I'm gonna do here is I'm gonna run the timer, because it's really good for us to kind of solve it under a time constraint. So we're going to get started here. And then we have 8 10 and 5 18. And then 15, 18, I believe the problem was. So basically, if we visualize the problem, So imagine that you had this interval here from 1 to 3. And then you had an interval here from 2 to 6. And then you had something like 8 to 10. And then you had 15 to 18, for example. So what I want to do is I want to devise a way to merge them together. So here we see that if we look at this number here, which is 1, 3, and then 2, 6, we know that these are going to merge together. So I'm going to use a different color here. So these ones are going to merge to 2, 6. So what exactly are we doing here? Well, we're taking this 1, we're taking this 2, and we're taking the minimum of them. And then we're taking this 3, and we're taking this 6, and we're taking the maximum of them, right? So that's going to be part of our intuition here. So it's going to be 1, 6, and then this one doesn't really overlap. So what I'm going to do is I'm going to color it orange, and it's going to be 8, 10. And then it's going to be 15, 18. And if you're just joining us in the chat, welcome. I'm just live streaming my Leetcode grind streams in preparation for my meta interview. But basically what we want to do here is imagine we had an answer variable here, which I'm going to color blue. What we want to do is we want to add this answer into the answer, and then we want to compare what this value is to the next iteration in our array, right? So we see here that 2 is going to be less than 3, so that means we had to merge them together, right? So for that fact, what we're going to do is we're going to merge them together and we're going to add it back into the answer. So that means that this is now going to become 1 and 6, right? And then we do the same thing. So since 6 is less than 8, right? That means we're going to add as is, and then etc., right? So that's how we're going to approach this problem in general. So what we want to do is we want to initialize an answer array, and we're going to go for, I'm going to call it interval in intervals. It doesn't matter, you can use I in range. Honestly, it doesn't matter in this case. So if not answer, we're going to add the interval. So we're going to go answer.append, and then interval 0, interval 1, else if answer -1. And we're going to go back to our whiteboard and want to make sure that we're going to check to see if answer -1 is going to be greater than interval 0 is greater than interval 0. Then what we want to do is we want to take the min interval is equal to min of answer -1, 0, and interval 0. Then we're going to take the max interval of maximum of answer -1, 1, interval 1. And then what we're going to do is we're going to set answer -1 is equal to min interval max interval. Otherwise, we know that it doesn't overlap, so what we're going to do is we're going to answer.append interval 0, interval 1. So now what we want to do is we want to return answer. Now we want to cover the edge cases, right? So I know I'm probably going to get complaints that it's too large, so let me just control zoom. Okay. Zoom, 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 zoom. Hopefully that's better for you guys to see the code that I'm writing. But and then we might have an edge case where the intervals are going to be out of order. So we want to go intervals, sort. So basically, if we analyze the time complexity and the space complexity of this solution, time is O of n log n because we did need to sort it. Space is going to be O of n because we do need some space for the answer array here. And then other than that, I think we're all good here. We could have an edge case where intervals, or maybe not. If we look at the constraints here, we can see that we're guaranteed to have at least one interval in intervals, so we don't have to worry about that edge case over there. So let's run it, and let's debug now. So 1, 4, 4, 5. Wait, isn't it the same? Alright, so let's dig into what's happening here. So we're forgetting the one case where answer -1, 1 is greater than or equal to interval 0, or not that, but the other way. Alright, cool. Alright, let's do the honors. And it is accepted, so that's the first problem down. Now I'm going to move on. Kth largest element in the array. So, given an integer array nums and an integer k, return the kth largest element in the array. Note that the kth largest element in the sorted order, not the distinct element. Can you solve it without sorting? So immediately when I'm thinking of this problem, the first thing that I'm actually thinking about is I'm thinking about, well, the brute force solution would obviously, if we were to sort it, and then we will return the k+1 element. But obviously here, we don't want to sort it, so can we do better? And the answer is, of course we can. What we can do in this case is use a heap, right? So we can use a heap, and then we can add values to the heap. So that's basically how it's going to work here. So we're going to create an outline of our code here. Sort the array, return k+1 element. Time complexity is O of n log n because of sorting. But space is constant because you don't need to use any auxiliary data structures in this case, but we can do better. This will improve our time complexity to O of n log k, I believe, with O of n space. So we do have a little bit of a trade-off here because we do have to add elements to the heap, right? But in this case, the time complexity will still be better. So, you know, it is going to be a solution that you'd probably go through in an interview, especially if you can't sort it, right? But I think it's good for you to kind of present these. Oh, I gotta reset the timer here. But anyway, we're a little bit behind, but you guys will kind of know. But that's kind of how you want to discuss trade-offs before coding the solution. Kind of fucked up with the other one with the merge intervals problem, but that's what I'm really trying to do is explain, trade-offs and whatnot before I actually start coding. So I'm going to also create an outline of the code or a pseudocode. So iterate. So first what we're going to do is we're going to initialize our heap. Then we are going to add each element to the heap through heap push. Then loop again through each instance of k. So let's see. Another thing that we might end up doing in this case that will help with our, well, not help with our implementation, but might affect the values of our implementation is the fact that we have negative values, right? So the fact that we have negative values means that, we can't just simply use a max heap. So when we're popping through each instance of k, I believe that we might need to do length of nums minus k to prevent ourselves from dealing with the negative case, right? So pop values from the heap using heap pop. Then return the first index of heap. Heap. So let's turn that into code. So for num and nums, heap q dot heap push heap, and then we're gonna have num. So we're gonna have another make sure, oh my god. Just make sure that I don't give a shit, bro. Yeah, that's what I want. So we're gonna return heap at instance 0. And there we go. And there you go. So that was cool. Reset timer. And we're gonna move on. This is why Python is OP, because basically heapq makes it so much easier. You don't have to implement the actual class. Alright, so kth largest element in the array. Let's do binary tree vertical order traversal. So as you can see here, I've already done most of these questions, but we're going to redo it. We want to make sure that it becomes second nature, because one of the things that I've noticed when I'm doing interviews is, you get nervous, and my goal here is really to make it second nature that I can just pump out the problems, and not have to worry about that. So that's kind of why I'm doing everything all again. But anyway, that's kind of the intuition here. Alright, start timer. So given a root of a binary tree, return the vertical order traversal of its nodes values. So from top to bottom, column by column. So here we see that we're going to return 9, 15, 20, and then 7, right? So when we're looking at this problem, there are two typical ways to traverse it through traverse the tree in general. So knowing that, obviously we're going to either use BFS or DFS. That's not going to be a certain question. So we see here that we can either go here, here, so it's going to go down and then back up and then down, back up. But there it kind of presents us with a potential issue here, right? Because how do we maintain the order, right? Because if we use DFS, we go to the right hand side, it might present a problem, right? You want to return it in a certain order, which is something I noticed when I was solving this question for the first time, is what it really matters. So in order to do that, I think what we need to do is we actually need to use BFS, right? Even though they're going to share the same time complexity, it's going to help us to retain the order. So I think that's a question that you would typically ask in an interview is, does order matter, right? Because that's, as you can see here, if you were to use a DFS solution, you go ba, 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 and then ba, 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 and then I can't tell if this is going towards here or here, if it's a 1 or the 0, but you can see here that 2, 8, so you go ba, ba, and then ba, ba. I think this one is going here. So actually you hit 2 before you hit 8. So how do you prevent that from happening? Well, you would need to use breadth first search in order to do it, because you would go level by level, right? So that's probably the approach that I'm going to take. So obviously, and then how do we determine the columns, right? In order to determine the columns, we're going to use a hash map, okay? So two possible solutions, BFS and DFS, have same time complexity and space complexity of linear, right? So we will go with BFS to preserve the order. In the case we hit a certain node first. Now that's not to say that you can't use DFS in this problem, but I just find that breadth first search is a lot easier. So that's probably what I tell an interviewer in this particular case. So what we're going to do is we are going to create our pseudocode. So I forgot to add, we will also use a hash map to store the what do you call it? The depth, I'll call it, and the nodes as its key value respectively. And you guys will see when I actually implement the code how this is going to work. But without further ado, we're going to get right into it. So firstly, I want to handle the edge case if not root, return nothing. I'm going to initiate my queue is a collections.pq. And what I want to do is I want to add two things, queue.append, and then we're going to add the root, and we're going to add a depth of 0, right? So while queue, and then we're going to have for blank in range length of the queue. Oh my god. Sorry guys if I'm scratching myself, I have a really bad case of hives, but yeah, anyway. Node is equal to q.pop_left. This is just standard breadth first search stuff. If node.left, I do like to set our breadth first search template. So it's going to be node dot left depth minus 1, because depth minus 1 is going to go to this side, whereas depth plus 1 is going to go to the other side, right? With node dot right q dot append node dot right depth plus 1. All right, so what's it complaining about? Oh, I forgot to pop the depth from that as well, because we definitely will need that. Another thing that we need to do is we need to initiate a hash map. And I actually skipped out on the pseudocode, but whatever. I would typically do that to be a little bit more methodical. So, but the code is pretty easy. I got way too deep into it. So, actually, let's go back, because we want to really practice how we're going to approach the problem. So I'm going to make it really quick. So if the depth is not in hash map, initialize empty list at depth in the hash map, right? Otherwise, the hash map at the depth. If left exists, dequeue it. If right exists, dequeue it. And then what we're going to do is, at the end, once we populate our hash map, sort the hash map by its key value, return the hash maps values. So that's basically what we're going to do here and what I'm trying to do, right? So I'm going to move back into the code here, right? Hash map at depth is equal to empty list. Otherwise, hash map depth dot append is going to be node dot value. Alright, so that's the queue logic here. Now I'm going to create sorted hash map is equal to dict sorted, and then hash map dot items, and then let me just make sure that it's actually sorted. I know it's wrong. -19, 0, 315, 120, and then 27. That's correct. -24, 9, 301, 8, and then 7, and then 4, 9, 5, 301, 8, 2, 7. So all we need to do here is we're going to return sorted hash map dot values. All right, and let's run her. And there you go. So basically, if I was in an interview, I'd talk a little bit about the time complexity. So the time complexity is going to be O of n log n, because you do need to sort it at the end, sort the hash map, and then return its values. The actual going through and dequeuing it is going to be O of n anyway. So the I guess you could say bottleneck is going to be that sorting. I think you could do better, but this is probably the solution that I present in an interview. It's the one that it's easy to come by, so I'm gonna work on trying to optimize it, because I probably want to be prepared for that. But that's probably the first thing that I would do, because obviously I got in 10 minutes, so I could probably optimize it in some way from there. But we're gonna discuss that another time. I think it's sorted now. As you can see, we're just booming through the problems here. Alright, so minimum remove to make valid parentheses. I think people have gotten this problem many times, so I think it's a really important problem to actually solve. So basically, let's go through it. So given a string of basically this sign and this sign of lowercase English characters, your task is to remove the minimum number of parentheses in any positions such that the returning parenthesis string is valid and return any valid string. Formally, a parenthesis string is valid if and only if it is the empty string containing only lowercase characters. It can be written as A, B, open parenthesis, A concatenated with B, close parentheses, or A and B are valid strings, or it can be written as A, wait, I gotta reset the timer here, where A is a valid string. So given here, we can see that Leetcode minimum remove. So they're removing one parenthesis. Oh yeah, I see now. So we got one parenthesis here, one parenthesis here, one parenthesis here, one parenthesis here, and one parenthesis here, right? So one thing we could do is we could kind of draw it on our good old whiteboard here. Erase. Alright, so if we have string Leetcode, so L-E-E, I think it's open bracket, open bracket T, no, not ChatGPT, C, O, D, E, and then I think that's the string here. So imagine we had a pointer here that's called char or something. So here's an index. We're gonna move through. We're not too concerned about this. However, we do need to make sure that we're converting this to a string here. So we're gonna go through here. We're not concerned about that. We're not concerned about that. But oh, we see an open parenthesis here. So what do we need to do in this case? Well, what we need to do is we need to add it to our stack, right? So this is going to be our stack. So we're going to add this open parenthesis here, right? T, we're going to see another opening parenthesis here. So we're going to continue to add to our stack here. Oh, I don't want to erase it. Fuck. I want to use a lasso tool. See? And then here we get a closing bracket this time, and we see that our opening bracket, or our stack rather, has values in it, so it is safe to remove them and not do anything with them, right? And you'll see kind of what happens at the end, because I've already figured this out before, but I just want to practice explaining my thought process. So O, not concerned about that. We see another closing parenthesis, therefore we're going to pop from the stack. Lasso tool, D, E, and then we're going to see an open parenthesis, but hold on a minute. Our stack is actually empty, right? So what does this mean? This means that we have to delete it, right? So we're going to delete this character, and we're going to return this, right? So that's exactly what our algorithm actually is doing. But how about in the edge case where we have close, close, open, open, right? So we can see here, if we move our lasso tool here, we can see that close, close, we're going to ignore them, and then we have open, open, right? And what did we do last time? Well, we were to delete the values, right? So we're going to remove this and this. But we can see here that we're supposed to return an empty string. So in this particular case, nope, that's not what I wanted to do. Open, open. So we have values in the stack, right? So what do we need to do? Well, we need to pop values on the stack and delete it at the same time. So this is going to be after the loop here, that it's going to be quote unquote another edge case, right? So that's basically how this algorithm is going to work. So I'm going to translate it to pseudocode. As you can see, it is technically a one-pass solution. So the time complexity is going to be O of n. We still need space for the stack, so it's going to be O of n as well, because at most we're going to append n elements. So that's going to be our time complexity and space complexity. And I think we covered most of the edge cases here. Obviously, another edge case is going to be is in an empty string, blah, 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 blah. But, you know, in this case, there's no mention of that. Could technically protect from that using a guard statement, but in this case, I know that it's not going to be inherently the case. So time complexity, O of n, space complexity, O of n. Alright, so what we need to do here is we need to create our pseudocode. So what we're going to do is, there's a couple things we need to do. Initialize stack, turn S into a list, call it R, because I'm lazy, and then iterate with char and index in enumerate of this R list if our char is an open bracket append to stack, else if our char is a close bracket check if stack is empty. If so, are going to set the character to nothing or empty string, right? If stack is not empty. Pop from the stack. Return the join of array to get the final string. Alright, so that's kind of how it's going to work here, right? And obviously we have time complexity. I can't really think of any other solutions that we could potentially think of, but this is probably the solution that I would present in an interview, right? So let's see. Stack is empty. I'm going to call this R is equal to list of S. No, you stupid fuck. So for I char in enumerate of R, if char is equal to open bracket, add stack, so stack dot append, and we're going to add the character, or should we add the index? I'm gonna add the index. Or do we need to add the char or the index? I'm gonna try the char first. Char is equal to, I guess it wouldn't really matter in this case. If not, stack, we're going to set R at position I to be empty. Else, that means we have values in the stack, so we're going to simply stack dot pop, right? But we're not done yet. What we need to do is we need to iterate R of vowels is empty, because you need to cover it for this particular version of the array here, right? Return join R. List indices must be integers or slices, not string. Hold on, let me isolate the problem here. Cool, that's what I want. So it definitely is the problem here. So we can see here that this is the problem. So let's see, if stack vowels in stack, let's see, we're going to print vowels right now. Okay, so if we add the index instead, what would happen here? Oh, there you go. So you do have to add the indices because you need to end up using it a little bit later. So yeah, that's a little bit of debugging there. And then what we're going to do is we're going to control. And there you go. And it's pretty efficient, again, O of n. So yeah. So that's kind of how I would debug it. I think that wasn't too bad, but yeah. Hooray! Next question. Valid word abbreviation. Okay, so I'm gonna choose to do Python because fuck Swift and their optionals and shit. So, a string can be abbreviated by replace. I actually solved this on my last live stream and I really struggled with it. I ended up figuring out what it was, and it was actually simpler than I actually thought it was, but I'm gonna kind of explain this problem. So, what we need to do here is we need to say we have a substitution. So I had to go in 10 minutes, so I'm probably going to end the stream after this problem. Oh, internationalization. So I think it's 12. IZ for N. So what we're going to do here is we're going to have two pointers. We're going to have one pointing at the word and one pointing at the abbreviation, right? So we're going to call this I. We're going to call this J. What we want to do is we want to check to see if the word in I and the word in J are equivalent. If so, we're going to increment both pointers, right? So we're going to move this to N, and we're going to move this to J, and we're going to also check if they're non-equivalent to each other, and if this one is numeric, right? Because if it's numeric, we had to devise a calculation to move this all the way over to whatever it is, right? So in order to do that, we're going to use a little formula, multiplier times 10 plus the integer value of 1, and then we're going to keep incrementing this pointer until we see while it's still a number, right? So we want to calculate how much we're going to move this pointer, and otherwise if we don't see a character that matches each other, then we're going to return false. Another thing that we might end up having is 0. We know that we can't have the a leading 0 in front, so in that case we will return false right away, right? So that's kind of the two-pointer solution there. So I'm going to explain it via pseudocode here. I know I'm rushing through the problem because I really have to go in like 10 minutes, so I really apologize for that, but I really just want to get this problem done before I head out instead of finishing this early. We're probably going to resume this problem and I'll explain it a little bit more in detail later on. But so time complexity O of n, because it's basically a one pass solution, plus m, because you had to iterate through both of them. And we have a linear space complexity because we are using two pointers. So here's our pseudocode. Initiate I and j pointers at the start of the word ABBR while the I is less than the word and the j is less than the ABBR, basically the length of the abbreviation, if word at I is equal to word abbreviation at j, increment both I and j pointers, else if ABBR j is numeric. Set a multiplier variable to 0. Check if ABBRJ is numeric again. If so, calculate the multiplier by multiplying the multiplier by 10 plus the character that we are on right now. Hamilton 33 says, do you have a sense of humor? I do not. I am basically a robot. As you can see here, I'm basically a moving AI that's pretty dumb. But in real life, I do have kind of a dry sense of humor, to be honest with you. But yeah. Increment J pointer. And I forgot the test case as well. If ABBRJ is 0, return false right away. Otherwise, return false. Check if both pointers are at the end of the array. Return a boolean where I is at the end of the word and J is at the end of the abbreviation. Alright, so that's our pseudocode here. So we're going to get started. J is equal to 0 while I is less than length of word and J is less than length of abbreviation. If word I is equal to word, or not word, but ABBRJ, increment I plus 1, J plus 1, else if ABBRJ dot is numeric. If ABBRJ is equal to 0, return false, set our multiplier to be 0, while J is greater than 0 or less than length of ABBR, and ABBRJ dot is numeric. So what we're going to do is we're going to take our multiplier times 10 plus integer value of ABBRJ, increment J, check if is numeric. Return false. Return I is equal to length of word and J is equal to length of ABBR. And of course, what we need to do as well is we need to increment I by the multiplier that we just created because we're not using it. And let's see here. Alright, let's see what she does. Accepted, Control C. There we go. We are accepted. So I know I went through that fast and I kind of didn't explain it in detail, but I'm unfortunately going to need to end the stream here because I have a meeting in like 2 minutes. So I hope you guys enjoyed the video. I hope, I appreciate you guys being here and watching me do a little bit of Leetcode, preparing for my meta interview. I'm being totally honest. I want to kind of create kind of like a vlog of my Leetcode progression. I think this is a good way to do it. But anyway, hope you guys enjoyed the video, and I'm gonna probably grind some more Leetcode on some other time. So I'll see you on the next video. And then before we go, let's see. Do you have a sense of humor? DAS delegate service time. I'm not sure what you're trying to say, Hamilton, but yeah. Anyway, I'm gonna end the stream here. Hope you guys enjoyed the video, and I'll see you next time.